Hi, Satya.
Hey, good morning.
Morning. Hello, everyone. Morning. Uh, Charlie,
Hey, your voice is breaking. Ishan, can you speak up?
Hi, Shan.
Yeah. I'm audible.
And you're loud and clear.
Yeah. Yeah. Just it's like am I on?
And Puneet, you're audible, but this is breaking.
Just a sec. Just see.
Let's wait for 5 minutes. Start at 9:35.
Yeah, Lamita ji, good morning.
Good morning. I attached my audio and video today.
Excellent.
Thank you. I was just wondering if Ishan, I got stuck at a question yesterday. So if it is, if you could share your telephone number, I'll send you the snapshot.
Is it about some code? We can do it right now, shall we? Or do we do it at the end of the evening session? Ishan, what is a good idea?
We can do it now till people are joining.
Okay. No, it was about true and false, that, I'm not turning my camera on, I'm sorry, because, yeah. But the thing is, we were discussing about true and false yesterday. And incidentally, I had come across an interesting function, where a variable was already called false. And then when we were using it in the function, inside the function, it was executing only the statement that was for true. So I found that a little amusing, and I couldn't quite understand, it made me think, because it was clearly, it's a variable that was called false, and by passing that value into the function, it wasn't executing it for false, it was doing it for true.
So was the variable called this?
FALSC, yes. Yes.
In this case, exactly this case?
Yes.
So this is no problem. It's just a bad naming of variables.
No, because
Yeah, I'll show you. I'll show you. Let me know if that is the issue that you saw.
okay. I thought I'll share that snap because I shared it in the group, and apparently you're not there in the group.
No issues. You'll just type it out right now.
You think that I should do that? All right.
No.
Yeah.
He's doing that.
He's doing it. Okay.
So you can do this. Okay. Was this what was being done?
No. I'll tell you. Can you write the function as I tell you?
You can just share the pic in the group again. I think it's Dr. Sachin added us just now.
Oh, he added you. Fine. I'm just sharing it. Yes.
Or
Yes, am I audible? Mr. Ishan?
Yes, Puneet, your order.
Yeah. Good morning, everyone. I, Puneet Sehgal, faculty from Department of Electronic Science, ARSD College. Welcome you all today to the day 2 of our current FDP on advanced Python learning. And I welcome you, Satyakam sir and Ishan sir, for today's session. And I welcome to all my esteemed participants for the same. Now we can begin for today's morning session. Over to you, Satyakam sir and Ishan, Mr. Ishan.
Thank you, Puneet, and yeah, glad to be here. And yeah, today let's make it more interactive, And instead of
Yes.
we just continuously talking, let's start with yeah, Ishan, we can take few minutes and do you have that code snippet with you now?
Yeah, I have it. So Lalita, we haven't done functions till now. We'll do that today. But I'll just type it as fast as I can.
Oh, yeah, but we already got an assignment on functions.
Oh, okay. They were supposed to be covered yesterday, but we didn't have time.
All
No
right.
worries, we'll cover it today.
Yeah, you may write down your name for first and last, as a matter of fact.
This is first. Right. It's similar to what you sent.
Not quite. If initials.
Not quite. Yeah, I mean, it's just the condition that you are interested in, right? Why is it coming as true?
Yeah, if initials print first the first character and last character.
Yeah, but the print statement is not important here. So
Right.
what this is what this initials is, it's a default argument.
Yeah, you may call it with your own first and last name. We'll see what happens.
Yes, you can call it with your own first and last name.
Yeah.
But so this initials, what I'm talking about initials right here.
Yes,
Forget about first last.
Right.
Initials is a default argument, right? So default arguments are those that if you don't pass the value, they assume the value that you defined while defining the function. So if you don't pass anything, initials will be false. Okay, so it will print this block here. Yeah, first,
that was the fallacy, because initials is explicitly given as false. Why did it have to print the case for true?
It didn't print the case for true, right? It printed this case.
Yeah, that case. I mean, that would be for true only, right?
No, this would be for false. So I'm using initials, right? Initials, if it's true, it will print this. If it's false, it will print this. So I'll just show you what happens if you like pass through in the function.
Okay.
So like I said, if you don't pass any value for initials, it will be false by default, right? But you can pass a value. You can also say that I want it to be false. Even though it is assumed by default, you can be explicit. So depending on what you pass, the condition is getting executed. There is nothing out of the way about it.
Okay. No, the if initials thing, this statement for if is executed for whatever value initials has, right?
No. It will only be executed if it's true.
Okay. So if true, which means this statement is true, then
let me just change to
because first, the first character, if you could just change that.
Last
0. The first character.
All right. Now this is your function.
Yes.
Okay.
Yeah.
So if I don't pass anything, initials will be false by default.
Yes.
Okay. So this condition will not run. This block will not run.
That's where I got stuck.
Yeah, this will run. So if I pass it as true, initials would be true, and now it will print this dotted, my name plus dots, 2 dots.
Yeah.
Okay.
Okay, so let's get started, Ishan. I hope that was helpful for everyone. So what all we are doing today is basically functions and a lot of data structures which we left out yesterday, and then we will move on to the object-oriented programming for things and advanced topics. Yeah.
Okay, so let me just increase the font size.
Flow control, we have just covered if statement, right, yesterday?
Yeah, if and elif else parts. Mm. So now we'll be covering while loop and for loops. So a while loop is a loop. So a loop is basically a bunch of statements that you run repeatedly, right? So depending on a condition. So a while loop is a loop that keeps on running until its condition becomes false. So what do I mean by it keeps on running? So Python has a while statement, right? Let's first go back to the age example, right? So my age is currently I'll set it to 15. Okay. What Python allows is you can specify a while statement and a condition. And what you can do is inside this while loop, you just write your normal Python code as you would have written before you knew about this while loop. So what I'm trying to do here is I'll keep on asking the user whether they are they what is their age, and if their age is greater than 18, I'll just print you are eligible to vote, right? So here I'll be repeatedly asking to the user. So I'll show you in a minute. Again, we are using the int constructor that we discussed yesterday, and I'll ask the user using an input function. We also covered input function yesterday. So input is please enter your age. Right? And what I can do is, like I said, just assume this whatever you write inside a while loop to be like generic Python. It's nothing different. So what I want to do is, if age is greater than what I want to do, if age is all right. Okay. So what I've done is inside a while loop, I've set the condition as while age is less than 18, ask the user about their age and tell them that they are not eligible to vote. So how does a user become eligible to vote when their age crosses 18, right? It's either 18 or greater than 18. So the variable I'm using for condition, the same variable I am taking as an input from the user. So in every iteration of the while loop, I am updating that age variable. So unless the user doesn't enter an age value greater than 18, this while loop will keep on running. Okay. So please enter your age. I'll write 10. Okay. It printed you are not eligible to vote. What happened was, first of all, it asked me, it checked whether age is less than 18. I set the age as 15 for starting, right? It checked whether age is less than 18. If it is true, which it is for 15, it came inside the while loop and it executed the statements line by line. Okay, the first statement is I asked the user for age, and what the age I've entered is 10. Okay, then I am print you are not eligible to vote, because I enter the while loop when I'm sure that the user is not eligible to vote. If the user has age greater than 18 or equal to 18, I won't even enter the while loop. Okay. So being inside the while loop, I know that this condition had to be true. Okay. So if I enter again 11, it will tell me you are not eligible to vote. Again, I entered 11 here. It printed this statement. Since it's inside the while loop, this condition must be true. So I know the user is not eligible to vote. Again, I'm going to enter 18, right? So when I enter 18, actually, okay, when I enter 18, so it will ask this. It will also print you are not eligible to vote, which is a bit wrong. But the next time it won't ask me for my age, because it would have exited the while loop, right? So this statement probably should have been at the front. So if I do this, at the start of the while loop, I just print you are not eligible to vote. You can just see how it will print the statement, right? So again, since age is, what is age now? Age is 18, so this didn't run, the while loop didn't run. I'll again set the age to 15. This while loop with print statement at the front, and age, I'm asking the age later. So what I'll do is, okay, so age is 15. It checked the condition is true, so it goes inside the while loop, right? And please enter your age. First of all, it informs you are not eligible to vote. Then it asks the user for age. Okay. So I'll enter my age, let's say 10, same as I entered. Again, it will go back to the condition. So what happens is, just to visualize, so this is a while loop, right? And this is a condition, right? And these are my statements. So it checks the condition first. If it's true, it goes inside the while loop, right? It executes all the statements line by line. Then it goes back and again checks the condition. And if it's true, it goes back again. So it's a cycle, it's a loop, right? When it has run these statements and it goes back to check the condition again in one of the iteration, and suppose the condition is now false, right? It exits the while loop. We call it exiting the while loop. So condition becomes false, all the statements inside the while loop are skipped. Alright. So to go back to our example here, I'll just enter 11 here. This entered 11. So and it went back to the condition, checked for whether 11 is less than 18, which is true. So since the condition is true, we execute the statements inside the while loop. I print I'm not eligible to vote, and I ask the user for age again. Now I'll enter 18, right? So notice what will happen when I enter 18. So where am I now? When I am waiting for the input, I am here. Alright, I am at this line. Python is waiting for my input. Okay, and so if I enter 18, age will be set to 18, and all the statements are finished, and the next time it will go to check my condition, my age would be 18, and is 18 less than 18? No, it's false. So it will skip the whole while state. Okay, so this is our while statement. So keep on running some block of statements until my condition is false, right? So this is keep on running the statements until the condition is false or falsy. Again, it goes back to what we did yesterday. It doesn't have to be false literally, it can be any falsy value. Okay. All right. This is the while statement, and any questions or any doubts till now? I'll wait for a minute. You can type yes or no in the chat as well. Anyone? No doubt. Yeah. Okay, that's good. Okay. So we'll now move to the for loop. All right. So for loops. For people who have done programming in C or some other language, that language, for loops in Python are a bit different. I'll show you how. First of all, let me show you an example of a for loop in C, the classic C. Right. So it will help you compare. I'll just quickly. So a for loop in C looks something like this. For int I equals 0, I less than 10, I plus plus, right? Person D and I. For people who haven't programmed, don't get bothered with the syntax. Just focus on the thing I'm about to tell you. Okay. So this is how a for loop looks like in C, and of course you have your hash includes there. Hash include stdio.h. Alright, this is how a for loop looks in C. The thing to notice is that what I'm doing is I'm specifying a start condition and a stop condition and an updation statement. So in C or in many other languages, you specify where you start, where you end, what should be updated, and what are the statements that have to happen in a for loop, right? By the way, for loop is a loop similar to a while loop. For loop executes its statements until the condition becomes false, similarly to the while loop. The difference here is if you consider the classic for loops from C family of languages, you specify the start condition, the end condition, the updation statement, and then you specify the statement, right? Python is a bit simpler. So let me just show you an example, right? So Python for loops look something like this. Okay, so notice the difference here. In C, there is a start, there is an end, and there is an updation statement. Okay. In Python, there is, first of all, it's very readable. Okay. Second, I haven't specified where to start or where to end anywhere. Right. And in Python, it is considered idiomatic, it is considered Pythonic to not do that, to not specify the start and end condition, right? So, even though we didn't talk about strings in this regard, but what it will do is, if I run this, it will print every character of my name. So what this for char in name does is, it iterates to every character in my name. First, it will go through I. Let me try to highlight it better. It will go through I, then it will go through S, it will go through S, then H, then A, this A, then N, and so on. Spaces A, O, R, O, R, A, right? Sorry. I should have printed the char. So what I did here was I printed the name that many times. So name is of course my string, so it will print name that many times. So I should have printed char. So as you can see, for a string, what a for loop does is, if I write a for loop like this, what it does is it iterates over every character in my string. Okay. All right. So how do I do this this kind of thing in Python? Here I am like what I'm doing is I'm printing numbers starting from 0 and going till 10. 10 being not inclusive, 10 being exclusive. Okay. How do I do that in Python? So Python has a special range function. What a range function is, a range represents a sequence of integers basically, right? It doesn't have to be integers, but for our purposes it represents a sequence of integers, right? So the range function takes two, actually it takes three, but for now it takes two arguments, similar to slices. So if you remember slices that we did yesterday, this is my name, right? Slices had these two sort of what I call they look like parameters, right? So this is the first number, this is the second number, and what it prints is the first two characters. So it starts from 0 and goes till 2, 2 being exclusive. So it will print the 0th and the 1th character at first position. Alright. So this prints this. Similar to the slicing logic, we have the range function in Python. All right. What it will do is as now this range function, if I press enter, it represents all the integers starting from 0 going till 10, 10 being exclusive. Okay, similar to slices. So one thing you'll find about Python is very cohesive in nature. So one part of the language behaves like other parts of the language. Okay, this is a pattern you'll find in Python a lot. So I enter a range, press the enter, and I get a range. I get this range 0 to 10. Right? Don't worry about what it's outputting. I'll just stick this thing in a for loop. For I in range 0 to 10. All right. Print I. Okay. What it will do is it will start at 0, go till 10, but 10 is exclusive. So it will go from 0 through 9. Okay. So as you can see, the for loop will iterate over whatever we passed on the right hand side. So since this range represents a sequence of integers starting from 0 going till 10, 10 being exclusive, I will iteratively get the value 0. Next time it will get 1, 2, 3, 4, 5, 6, 7, 8, 9 until the range is exhausted. Right? So until the range is exhausted, I will keep getting on the next value in the sequence. So first it will get 0, then 1, 2, 3 and till 9. Right? And inside the for loop, I am printing I. I could have just as easily done anything else. Right? It's a normal block of Python. Whatever we have done till now, you can do in this block. Right? Mind the indentation, because we are using a colon and it defines a colon and indentation, define a new block in Python. Right? So mind the indentation. So I'm just printing I here. What I could have done is I want to print the square of I. Right? How do I do that? So since it's just normal Python, nothing special about it, what I can do is I can do this. Okay. So as you can see, now I'm printing the square of I in every iteration. What happens is I still gets, I'm using the for f strings here. So all right, I'm just printing I first, and then I'm printing the square of it, right? Just to show you how the value gets transformed. So I still is getting the value from 0, 1, 2 till 9, right? What I'm doing is I'm transforming a value, and I'm instead transforming I into its square. Not into its square. I am like transforming. I'm getting a new value from I here, right? I can do any operation with I here. Right? I is still going from 0 to 9, but what I can do is I can even do this. Now it will print the cubes of I. Okay. First it's printing I, then it's printing cubes of I. Right? I can go crazy with it. I can import. Is it a power function, right? Yeah. What I can do is I can print the powers of 10 here. I raised to the power 10. So 0 raised to the power 10, 1 raised to the power 10, 2 raised to the power 10. You can see the power of it, right? You can do anything here. I am just printing stuff. You can do transformations. You can put while loops in here, you can put f strings in here, you can put you can do operations like I've done here. So anything that you've seen till now, you can do inside a for loop. Right? Same with the while loop. Okay. I'll pause for a bit here. Any questions about a for loop? Yeah, Lilith, I just made a mistake. I printed the name instead of char, but you see what it did there, right? So I'll go back to the example. It is like a good exercise to understand what mistake I made. So for char in name, what I did was I printed the name, right? Let's take an easier example. Word equals, all right. For char in word, remember for strings it will iterate through every character, right? FOUR, print word. Can you just type in the chat or like unmute yourself maybe and tell me what it would print? So I now word is a string which has the value 4, and for every character in word I am printing word. What would it print? 4 times. Okay. Anyone else? It's a good exercise to like. Okay. I'll just go back, and you are correct. It will print the word 4 times. Why? Because for every character, it will do these statements for every character in this word. Okay. So since I am printing word and word is 4, it will print the word 4 times. What if I had done this? 5. How many times would it print now? Makes sense to print 5 times, right? Anyone? 4 times 5. 4 times. 5 4 times. Yeah. Yeah, correct. It's not intelligently thinking that, oh, I have to print it 5 times. It is just it will just literally take whatever you put in a string and for each character do the thing you have asked it to do, which is printing the word, right? So okay, this is a for loop. For loops are in general more powerful than this. We'll look at it when we complete lists and some of the data structures. We'll come back to the for loop. Okay. And notice one thing, which is like peculiar to Python. This style of for loop is present in some other languages, but Python, I find Python's for loop syntax to be the most readable of all for loops for languages. Okay. C is obviously a bit verbose. You actually want to print the integers, but you have to care about starting, ending, and updating. In Python, you just have to simply remember that this for this range function exists and just print the i's. It's very simple and readable. Again, the ethos of Python is very simple and readable. Okay. Now we've covered major flow control statements. A few statements that we haven't covered are these are break and continue. Alright, I won't cover them here, but I'll leave them as an exercise for people here to read about break and continue. So what break and continue does is, suppose you are inside a while loop or a for loop and you want to prematurely end that loop, right? You got what you wanted and you want to prematurely end. You don't want to go through the end of that loop. To prematurely end a for loop or a while loop, you use the break statement, right? Continue is for skipping the current iteration of the loop. So there are times when you have a condition and you want to skip the rest of the loop. So there are some statements. Let me just. So suppose you have a while loop, right, and you have a condition here. You have some statements, right? You have a flag or some sort of something set here that you got what you needed. There are some statements after this flag as well in the loop. Remember, we can have multiple statements in the loops, right? These are just normal Python statements. So what we want to do is we want to skip these statements. We want to skip the current iteration. So what we do is we put a continue here. So what continue will do is it will skip this current iteration and it will just go back to the condition, right? Normally in a while loop, what happens is you check the condition, you execute statements line by line until the end of the while loop. All right, and then you go back and check the condition again. But what continue does is continue makes it so that you skip the statements below continue. These statements are never executed. Not never executed. These statements are not executed for the current iteration, right? And then you go back to the condition. You go back to the condition and you check again. So this time this flag might not have been set and you would go through the end of the loop. Okay, then again you check the condition, normal while loop semantics. Okay, so I've explained them, but I'm not showing them how you do that in syntax. It's you can look that up yourself as well. All right, functions. So let me go back to my terminal. By the way, this if people didn't have this thing before, I'm sharing this link again. Okay. All right. So we've covered flow control. We covered if else yesterday. We covered while and for loops today, and so one extra thing I'll cover is this is a you can say shortcut of a sorts in Python. So I have a variable. It's a Boolean variable because I have assigned the value true to it. Right? It's a type. Again to reiterate, type eligible. Right? If you want to see a type of a variable, just pass it in the type function. Get the type. Right? So eligible is true, and you have your age, right? You ask the user to enter your age. Again, it's a very common theme for us now. Excuse me. Okay. So yeah, enter your age. I entered 10. Should have left a space there. I entered 10. So my age is 10 now. Okay. So we this sort of idiom arises many times in Python when you want to set a value depending on some other value, right? So I showed you eligible, right? What I want to do is, if my age is greater than 18, I want to set eligible to true. Else eligible is false. Okay. This sort of pattern arises several times in Python. That depending on value of one variable, you want to set the value of a different variable. Okay. So since I entered age 10, it will show me that I am eligible. I am not eligible. So eligible is false now. Okay. So for in Python, what you can do is you can shorten this. If you have a if and an else, and this sort of idiom that depending on value of one variable, you want to set the value of a different variable. What you can do is you can say something like this, right? So for people having experience with other languages, this is similar to a ternary operator that we have in other languages. But in my opinion, it's much readable. Okay. So what it says, read it as eligible is true if age is 18, else it's false. Right? Very readable. If I do this, eligible, it's false. Okay. So this is a very common idiom in Python to do this. Depending on value of one variable, you set the value of a different variable. Okay. This is the closest to what you would call a ternary operator in Python. It's not actually ternary, it's an expression. You could say that it's a ternary operator if you really want it. Alright. Functions, yeah. Coming back to functions. So, what are functions? So functions are a reusable piece of code that you or some other person wrote, and you just use them in your programs, right? So a good idea to think about function is I have been doing this if age equals 18, eligible is true, or not this. An example more complex than this. Let me go back up in my history to find a more complex example. Not a while loop even. This is a function, by the way. Let me just give me a minute. All right. This is a good enough example. Right? So this is a piece of code that we wrote yesterday, and let's see what is age right now. Okay, it's 10. So this function will not print anything because it's a single if. Okay, it will check the condition. 10 is greater than 75, which is false. It will skip the whole if statement. Okay, so what you could have done is you could have defined a function and you could have said check senior citizen. Okay, check senior citizen we'll do just we'll print for now. Okay, so what am I doing here? This is, by the way, new syntax for us. If people are familiar with Python functions, they would know, but this is new syntax for us. Right? What did it do? So what it did was it created a new function named check senior citizen, in which it takes an argument. I'll talk about arguments and parameters in a bit, but it takes this age argument and it checks whether age is greater than 75. If it's true, it will print you are a senior citizen, right? Let's just try out this function. Right. It will do nothing. 11, it will do nothing. 75, it will do nothing, because the condition is to check greater than. Okay. 76, yeah, you are a senior citizen. So what did we do here? So if you notice, what we are doing is similar to what we have been doing since the start of this session, start of this course, right? What's this? This is also a function, right? What's this? This is also a function. Type is a function. Bool is a function, right? Any number of things that you have to print even. Print hello world. The first thing that we started with this course. Print is also a function, right? What is a function? So,
yeah, Ishan, you can show them how to get help with the help function, Help
sure.
Find anything, right?
Yeah, of course, yes. I'll talk about that as well. So, so we've been using functions all along, right? So how do you identify functions in Python? A general rule, although this is not true and then there are many exceptions. What you can see is there is a name followed by a parenthesis, which is this bracket that is on above the 9 key, followed by something ending with closing bracket, closing parenthesis, right? This is what you can think of as a function in Python. So what is a function? Function, as I said, is a reusable piece of code, right? So of course I didn't write this end function, I didn't write this type function, okay? I didn't write this bool, I didn't write print function. So, but someone wrote those functions and helpfully provided us with those functions. So Python comes with a very rich library of functions that you can use. Okay, this int, type, bool, print are one of the few functions that Python provides. Okay, so just to give there is a list, right? Python built-in functions, Python docs. So these are some of the few functions that you can just use in Python without even doing anything, right? No need to import, no need to pip install. You can just use these functions. These are what are called as built-in functions, right? Built-in means that you don't need to do anything extra to use them, right? There are some functions in Python that are very, very useful, but you need to import something to use them, or you need to pip install something, that like we did with Jupyter Lab, that those are not built-in functions. These are built-in functions. So I'll also add this link to the slides as well, to the Jupyter node, right? This is a very useful list to know which functions are built-ins. Okay. So like I said, these are built-in functions, right? You can even define your own functions in Python. Okay, similar to any other programming languages, you can define your own functions. And how do you do that? You use the def keyword. Okay, again, this is a keyword. So any word, any symbol that I say is a keyword. You can't name your variables that symbol. So I can't have a variable def equals 50y. Okay, it will give me a syntax error. Yeah. So def is a keyword, a reserved keyword, you can say. then you give the name of the function that you want to use, right? It can be any name. I could have just as easily named it check senior citizen. I could have named it like this, check senior citizen, right? It doesn't matter what the name of the function is. You just need to remember the name of the function. I'll just print you are a senior citizen. I won't check the age here, right? Just to show you. So you can name it anything you like, okay? But notice what I named it here, right? Notice what I did this. I named my function with the words separated by underscores. Every word is in small letters and they are separated by underscore. This convention or this style of naming things is what is known as camel case. So it is used by Java, JavaScript and those family of languages. Not those family, but in general, this is mostly from Java, and this is what we use in Python. It's known as snake case. If you remember that we talked about it earlier, this is known as snake case. This convention of naming functions and your variables is known as snake case. Okay, so fine. You write the def keyword. you you name your function whatever you want to name it, then you write starting parenthesis, and then you specify here what values you want to take as input. Okay, these will be the input to your functions. These will be the formal name for them is the parameters for your function. Okay, these are known as parameters of your function. So here you name your parameters, you define your parameters, and you can have more than one obviously. And then inside the function, you can just use those parameters and do things with those parameters. Anything that you can do with Python, the things that we've been doing since day one, you can do inside a function as well. Okay. So this is a function in Python. Okay. To go on a tangent here, this is a function, right? 0. This is a function int, right? So how do I know what arguments it takes? And in a multi-Python file, it's sometimes very confusing. What parameters? I'll talk about parameters arguments in a bit, but what parameters a function takes and what values it returns. So in this case, my function isn't returning anything. Okay, it's not doing a transformation on a value and returning that value. It's just printing a thing. Okay, it's just a helper function for me currently. So how do you know that what a function does and what parameters it takes and what values it can return? You can use the help function. Okay, so help is also ironically an inbuilt function, and if you see here, it will be inside H. All right. So you can see help is also a function, and in help you can pass any function or any object as well. So I'll just we'll talk about objects later, but I'll pass in the int function. Okay. So what it does, it provides. We looked at this by the way yesterday, but what it does is it provides the help on this particular function. Okay. What it does is it gives me the how do I use it? How do I use a function? Okay. What parameters does it take and what does it return? So it says that convert a number or string to an integer or return 0 if no arguments are given. So by reading this, we can infer that this function, if we don't give it any argument, it will return 0, right? And again, it says if x is a number, return x dot dunder int. So we might talk about these methods, but ignore this for now. For floating point numbers, this truncates towards 0. Okay, if x is not a number or a base is given, x must be a string, right? So by reading this help, you get a sense of how to use this function. Okay, how did the Python people intend you to use this function? So Python helpfully has very excellent documentation, both on uh, functions, modules, everything, and tutorials. So Python overall is one of the best documented languages that I have come across. Right? These sorts of explained and every case is mentioned. You don't regularly find this in other languages, but in Python it's very common to so this is giving me some other methods as well. Uh, so I can what I can do is just go a bit down. Yeah. So int by going to the help, I see that in the integer class, we haven't talked about classes yet, provides a bit count method. Okay. So let's just use this bit count method. Right. Right. So by going to the help, I got to know about this bit count function, which is very interesting. So it gives me number of ones in the binary representation of the absolute value of self. Ignore this self and such things, also known as the population count. So bin 13 is in binary 1101, and the bit count would be 3 because it has three ones in it. Okay, so reading through this help, you can explore and you can discover more functions, right? This is, by the way, how I discovered many of the functions in the random module. So we haven't talked about modules yet, but it's a similar concept here. I type help random and it gives me all the functions that this module has, right? So for example, I'll just go through the function. One of the functions I know, randint return a random integer in the range a to b including both endpoints, right? So I don't know about you, but I wouldn't find this method if like I wouldn't find this method anywhere. It will be in the documentation, but to discover it while reading a help manual is a very nice feeling to have, right? And you get so much information from here. You get uh, new functions, and you get familiar with the conventions in Python. That I would recommend absolutely to go and read a help page for a module or even a function that you like to use. Okay. Similar is the concept with man pages in Linux. So on a tangent again here, man pages are manual pages. Apologies for people on Windows, but for a command, suppose yesterday someone asked what makedir was, right? So what you can do is you can just type man, stands for manual, and just pass in a makedir argument, right? So again, argument parameters displays their here as well, but it's in a different setting now. So you can see this is a manual page for makedir create the directory. So exploring this, exploring your environment, your be it Python, be it your shell, be it Linux, is a very good thing, for very good trait to have in a program. Okay, so learn to get help. It is what I would say. Just use the help function. Okay. All right. Going back to the function. Any questions till now, by the way? I'll wait for 2 minutes. Any questions till now? I'll assume no questions. And so coming back to functions, right? We had our function def. This function, as you can see, takes one argument called age, and it does some checks on age, and it prints depending on whether that check was successful or whether that condition was true or false, right? So again, I'll define this check senior function, check senior citizen. Usage of function is its name followed by parenthesis and any arguments that the function expects. So while defining this function, I said that it would take an age argument, right? While using the function, what if I don't pass any argument, right? No, I am a newcomer to Python, so I don't know this function takes an age argument. So what happens if I don't pass any arguments, right? So again, I would say this. I would repeat this again. That don't be frightened by these errors. These are not scary. It's scary at first, but you should get in the habit of reading these errors, right? These are very important parts of Python. One of the very important part of Python is reading error messages. It is telling me that okay, it's in this line, and the error is actually a type error with some more information. That check senior citizen is missing one. It's even telling me what the argument I have to pass, right? So since I know this age is since I defined this function, I know that I have to pass an integer, right? What if I passed function 9999 in a string here? Notice that nowhere in my function I've defined don't associate a type, don't declare a type with a variable, right? You associate a type when you associate a value with a variable. You now age is 9999 in string. This is a very important thing. Nowhere is it checking that age is an integer. Okay, whatever you pass it, it will take that happily. Alright. When you go to execute the statements inside the function, and if that string is not applicable in a statement or an expression, that is what will cause the error. Right? Calling the function will not cause the error. It will happily accept any argument. If I give it a bool, it will happily accept an age that is a boolean. That doesn't make sense to you, but for Python, it isn't anything different if you pass a boolean here. Okay, it will just bind that name to that value. So age will now be true if I pass true, right? And is true greater than 75? I mean, does that make sense? So here it is telling me uh, the uh, the error occurred in this. First of all, this is telling me that the error occurred in this while calling this function, and inside this function in check senior age, what in the particular line that is the culprit is the second line of the function, right? It also you can see it is also helpfully providing me the line numbers of the function, right? So uh, so recent Python versions starting from 3.10, 11, 12 have drastically improved the error messages. So if you are on a different Python version, on an older Python version, you might see different error messages. But if you are on 10, 11, 12, you are very, very lucky to have these good error messages, right? So this is checking that if, so the culprit is this line, if age is greater than 75, and what the error is again a type error. So what it's saying is that this greater than operator is not supported between instances of string and int, right? I can check this on my REPL as well, this Python interpreter as well. So what I can do is I can type 9999 greater than what was my check 75, right? And get the same error, right? So this is a pattern that I like to use, not in just Python, but in other interpreted languages as well. First of all, I try out my logic or whatever thing I'm building inside an interactive session, right? I try out various values. I try out what errors it can give, what limits it can have. Then if I'm satisfied with that part or logic, I then integrate it into a bigger logic, bigger complex function or a complex class. So this is the workflow that I like to use. So that is why I showed you that if you want to try this, just try it on a REPL. Okay, Python is a REPL native. Python has a native REPL, right? Although I'm using an IPython, let's go to normal Python interpreter. Although not so fancy, it is still a proper. It is the official Python interpreter. So it will give me the same errors. It will give me the same error. It's just that this IPython, the interpreter that I'm using, provides error highlighting, syntax highlighting, and all sorts of error highlighting as well. So it's really nice to use. But uh, I think we can take a 10 minutes break right now. The robustness principle. Can read about it as well. I think I can actually show this robustness. I am forgetting the principal name exactly. It's called computing. The person who coined it, I'm forgetting the name. Uh, Robustness. Yeah, this is the principle, but it has a name as well. Postel's law. Yeah. So this is the Postel law. Be conservative in what you send and be liberal in what you accept. Okay. This is a good advice for not just Python, but in computing in general. Right. So yeah, I'll take a 10 minutes break right now, and we'll meet again at 57. Okay. Or we can make it 11 and just
Yeah, 11 is okay.
okay. Okay, I'm back now. We can start.
Yeah, we can start now, and let us know how's the pace and all that, huh? So that we have to do still a lot of things, right, Deshan? So can increase the pace if you want to. I don't know how people are drawing right now when we are doing this.
Okay, so now we'll talk a bit more about functions, and here I've opened the official Python tutorial. I'll also add this link here, okay, just for reference, and I'll also paste this in the chat. Okay, so I'll be taking this example from the documentation. Yeah. So as we've seen, this was our check senior citizen function, right? It took an argument age, which we checked inside the function and did something with inside the function, right? So how did we call this function? We called it, let's just assume it takes an integer and just call it with 10, right? 78, right? So we defined the function to take the argument age, right? So we could have just as well said, instead of just passing the value 78, we could have said this. Alright? This is the same thing. This and this are the same thing. Okay? So Python has the concept of what is called a positional argument and a keyword argument. Okay? Positional and keyword. Right? So by default, if you don't specify anything, if you don't change anything, you just say my function takes in age. By default, you can pass it. Okay, let's first talk about arguments and parameters, right? So while defining my function, whatever variable name, whatever name I pass here, I put inside the parenthesis. I call that variable a parameter, right? It's a parameter, right? Versus when I use the function and I pass it a value, the value I pass it is known as an argument. So I say that I am passing 10 as an argument. Okay. So this is just a bit of nomenclature that we have. The thing that is in the definition of function is parameter, called parameter, and the value that we pass while using the function is called an argument. Okay, this is a short tangent from what we did. So we were discussing about if we don't do anything, if we just say that this function takes in this function has a parameter age, by default when I call the function, I can pass the argument positional in a positional way or a keyword argument as well, right? So like I showed, I did this with check senior citizens, right? Check senior citizens. I also showed age equals 78, right? So let me just copy this example, this parrot example from the docs, and it's a function that takes parameters. It has parameters voltage, it has state, action, and it has a type equals Norwegian blue. Notice one more thing, right? in our check senior citizen function, this age is just a name. We have just passed in inside the parenthesis, right? You can call it a normal parameter. All right. In this parrot function, voltage is a normal parameter. All right. This state is also a parameter, but what's special about it is that I have passed in a default value for it. Okay. So if I don't pass a state in my function while calling it, Python will by default assume that state is a string which has the value a stiff. Right? Similarly is this action parameter, this type parameter. Okay. So these are called default parameters. When you put a name and you say equals some value inside the parenthesis while defining the function. Okay. So I've defined this function, and I can call it in various ways, right? So this parrot can take voltage as so by default, since voltage is not a default parameter, it will. But I'll use parameter and argument interchangeably. So just understand to the context what I'm talking about. So this parrot expects a voltage argument, right? Even if you don't give it a state, an action and a type, it will give it some default values. But it expects a voltage argument since it's not a default value. All right. So again, same thing. We'll call it without any parameters. So it says that missing one required positional argument, voltage. All right. So we'll pass in voltage. What does the documentation pass? Okay, 1000. All right. Okay. This is what this function printed. Now I could have also passed voltage as this, right? Remember, by default, I can pass an argument. I can pass it as a keyword argument or as a positional argument, right? Positional meaning I just pass the value. Keyword argument, I specify the name equals then the value. Okay. So this is a pattern you'll see a lot in Python. Keyword arguments are very popular in Python. Some languages like Java don't have them. So they're very, very useful in Python as well. In Python, not just as well. So yeah, I can pass the 1000 as a positional argument or a keyword argument. All right. Here. Now, I'll just copy this one. I'll just copy this and I'll just paste it. What it's doing is it's passing the voltage argument. Remember, this parrot will take one argument. It has to take at least one argument. Okay, because we defined it like this. Others are default. We pass it, it's okay. We don't pass it, it will take the default value. Okay, but since voltage does not have a default value, we have to pass in an argument, and we can do that in two ways: positional or keyword. Okay, that's true for any argument. Even state we can do that. Even action we can do that. Even type we can do that. All right. So here I am passing voltage as a keyword argument and action also as a keyword argument, right? So notice that this is voltage and action as a keyword argument. Okay, I am skipping state and I am skipping Norwegian blue type. So Python will understand, it doesn't care if we only use keyword arguments, it doesn't care about the order we pass in the arguments. Okay, this is what it will print. Next is as you can see in the comment here, we are again still passing two keyword arguments. Remember, we would always have to pass voltage because the definition says that it requires that. Okay, so here we are passing positionally, here keyword, again keyword, but with an extra keyword argument, here to keyword and a keyword argument and a different keyword argument as well, right? I'll just paste this. Again, no error. This might be a bit confusing, but if you understand it, the voltage is this part, right? I can pass it as a positional argument or as a functional argument. If I do it positionally, if I pass arguments positionally, Python will put those arguments in those parameters in order. So here a million becomes voltage, a breath of life becomes state, jump becomes the action. Alright. Now remember, if we are just using positional, the order matters. If we are just using keywords, the order doesn't matter. Okay. Again, we can mix and match those. We can pass some positionally, we can pass some keyword arguments. A thing to note is that positional arguments always are passed first and before keyword arguments. Okay, I can't say this state equals this and then breath of life. Right, single quotes. Remember, if I pass in a keyword argument as the first thing, I have to pass all the others as keywords as well, keyword arguments as well, because positional arguments are always passed first, and here I'm not passing it first, so it should give me an error. Positional argument follows keyword argument, right? So if we are using positional, just use them first and then all the keyword arguments. All right. These are some of the invalid calls. I showed it, right? Required argument missing. The definition says that it requires one voltage argument. Rest are all defaults. Okay. Default arguments. Default parameters. Next is parrot voltage equals 5.0 dead. Again, we saw this. It is positional after keyword, that is not valid. Positional will always be first. Then parrot with positional and voltage. So this is interesting. So I am passing the value first argument as positional, right? So Python will put that in order. It will put that in voltage. But I'm again passing voltage equals 220, right? So I'm again saying that voltage should be 220. First I'm saying it should be 110 because of the positional argument. Then I'm saying it should be 220 because of the keyword argument. It should give me an error. Parrot got multiple values for argument voltage. Okay. This is basically this. Yeah. This also. I haven't defined any actor parameter here, so I can't pass that in a function. Okay. I'm nowhere defined that I am taking an actor as an argument. So yeah. So yeah, this is the thing. Any questions still here? I mean, this is a bit confusing. Even now, sometimes I make mistakes between positional and keyword arguments, but if you don't understand it, it's totally fine. This is a complicated thing that is specific to Python, I would say. Any questions? All right, no questions. So I'll continue. When we come to star args and star quarks, so this is a pattern that you'll find in Python a lot. Frameworks like Django and other frameworks as well extensively use this feature of Python, this star args and star quarks. You'll also see that mentioned in a lot of documentation, a lot of tutorials. So what are these star args and star quarks? Right? Let's go back to the parrot function. So this function takes a finite number of arguments. It can take voltage, it can take state, action, and a type, right? If we don't specify any of these, the default values will be set by Python, right? It takes at least one, but at most 4 arguments, 1, 2, 3, 4, right? So it takes 1 to 4 arguments, this parrot function. But it is sometimes useful to take an arbitrary number of arguments, right? Sometimes I don't know what my argument will be. At runtime, I decide, using the name or the value, I decide whether that argument is useful or not. So, I mean, you would see this example in tomorrow's tutorial when you see Django, but while defining a function, what I can say, and remember, this is while defining a function. The star args and star quarks business is while defining a function. So when you are using the def keyword, that is when you declare that your function can take star args and star quarks. Okay. So just to simplify my example, I'll just say this. I'll just delete all these lines and I'll just print voltage. Print voltage. Voltage is the variable, sorry. Okay. And I'll also print args and quarks. I'll explain what these mean in a bit. Okay. So parrot function now declared that it can take args and star quarks. What does that mean? In short, it means that this function can now take an arbitrary number of arguments. Okay. Normal functions that we use are they take finite number of arguments that are defined when you define the function. So it's either 1 argument, 2, 3, 4, however many you define in the function. But these star args and star quarks, what they do is they allow your function to take arbitrary number of arguments. And how does that play? So again, this function defines that it takes voltage parameter. So again, this thing is true. It will require 1 argument. All right, voltage is required. I can pass it through 10. I can pass it through voltage equals 10. Parameters can be passed positionally or using keyword by default. Alright, but I can also now pass actor equals Ishan. Okay. Oh, sorry. The function. I should have just printed this. Yeah, my bad. So this is our function, and what I'll do is I can pass actor equals Ishan. So notice what it will print. It will first print voltage. It will then print hours. It will then print quarks. Right. Notice what those are. It will. I'll explain in a bit as well. Alright, notice one thing. Nowhere in the function I defined that this function is taking an actor parameter, an actor argument, or a last name argument. Right? Nowhere in the function I defined that. And I can do any sorts of like I said, it's arbitrary, right? Another thing. Let me go back to the let me again define this. Alright, just so that it is on the top. What I'll do is I'll now pass voltage positionally. Remember, voltage is a normal parameter. You can pass it using keyword, using positional arguments. 10, 20, 30, 40, 50. Alright. What does that print? So it printed voltage first, then it prints hours. So in our case, voltage is 10, right? So it prints 10. But notice my cursor is acting on this. Just give me. Yeah. So notice that this second line print hours printed this thing, right? And remember, the keyword arguments have to follow all positional arguments. So positional arguments have to be before all the keyword arguments. Actor is this, last name is this, and age is 22. Now notice what gets printed. Alright. So this 10 is my voltage, right? Because one argument is required for parrot function. The next parameters you can see get collected in arcs and quads. And how do they get collected? If you notice, the second line printed is being arcs, third line is being printed is quads. So all the positional arguments that I didn't define in my function get collected in arcs. I defined a single voltage argument, right? It's 10. So it got assigned to 10. Python did the right thing and assigned 10 to voltage. Alright. The next positional arguments, because we didn't define those in our function, we didn't say that, okay, second is maybe the the wattage, third is maybe the current. We didn't do that. We just did star arcs, right? So what happened was all the unnamed arguments, unnamed parameters, unnamed positional parameters got collected in arcs. All the unnamed keyword arguments got collected in quarks, right? What I'll do along with this, I'll also print the type of arcs. Right? Let me just print this and again the same example. Notice this again voltage. We defined it. We told it that we are expecting a voltage argument. So Python assigned 10 to the voltage. Remaining all positional arguments got assigned to args. Remaining all keyword arguments got assigned to quarks, right? And even though we haven't done data structures in Python till now, notice that args is a tuple, or you can call it tuple as well, whichever floats your boat. And quarks is a dictionary. Okay. Now we can do some complicated, a bit more complicated thing. Now don't expect you to understand it, but we'll just see that when I say that all the unnamed arguments get collected in args, all the unnamed keyword arguments get collected in quarks, right? So this example hopefully might clear that. Again, I call parrot, but instead I pass name equals, let's pass Satya now. We've been doing Ishan a lot. Let's pass Satya. As you can see, notice the difference between these quarks and these quarks, right? I should have printed name also. Print name. All right. Apologies for this. Yeah. So notice the difference between this and this dictionary. It's a bad example. My bad. Oh, wait a minute. Let's do without name. All right. Let's do without name. Let's call parrot without anything, right? Actor is subject. Okay. So all the unnamed positional arguments get collected in args. All the unnamed keyword arguments get collected in quarks. Okay. So here I'm calling this 10 is voltage. It is a named positional parameter. These all are unnamed, get assigned to quarks. These all are unnamed keyword arguments. They get collected in quarks. Okay. Now I'll define the parrot function here, and I'll change the definition a bit. I'll say actor is Ishan, right? So you can mix and match between these quarks, args, default arguments. So I say this, and I print actor here, right? Print actor. And I do this actor equals Satya again, right? Notice that since actor was a named argument, I passed it as a keyword argument. It didn't get collected in quarks. So remember, all the unnamed parameters get collected in args and quarks. So args is for positional parameters, quarks is for keyword parameters. Okay. Any questions till now? I mean, this is the most complicated thing that we've done till now. So if don't understand it, it's fine. This trips many experienced people as well, but go and when you get time, go and just read this uh, control flow, and specifically this link. I should have copied this link. Go and read this link.
Sean, there is a question the chat session.
Yeah, just a minute. Yeah. Will args always take numerical values? No, Hira. Args. I'll just change the parameter, right? Hello. I'll make it a list. Even though we haven't done lists, I'll make it a list. Right? It can be anything. The type doesn't matter. Okay. Any other questions? I would suggest you read this, the link that I've shared. I'll also share it in the chat if someone wants to save it. It is present in the sheet as well. This. Any questions? The important thing to remember is things get collected. Remember the word collected. That will help. So yeah, these are functions, and anything else in functions. I mean, functions are a whole topic on their own. We can like spend 2 days just on functions, but we should move on to data structures in Python. All right. So Python's one of the major features of Python, you could say, is that it gives you inbuilt data structures. Very powerful inbuilt, very versatile inbuilt data structures. You don't have to depend on a third-party library or install something else. Python has these things inbuilt, right? It's there for you to use. So just a quick question, have people used any of these before? For people who have done Python or have experience with Python, have you folks done this list, tuple strings and something before? Lalita says yes. Anyone else? Okay, Rashmi also says yes. So for those people, I hope that you learned something new today about these data structures. All right, let's start. And by the way, on the Google Colab notebook, this list is a link to a different notebook. I'll share the link as well. So if people who want to follow can do this as well. And by the way, this is adapted from this GitHub repository, so you can check out this as well. It has some other notebooks as well, which we don't cover here. All right. So I'll just share it. Okay. I'll just.
No, not here, not here. Oh.
I just want to share this Colab link.
Collab link you should do in the WhatsApp group.
This is in WhatsApp group as well. I'll share it in the WhatsApp group as well. Let me just give me a minute. I'll share it in WhatsApp. Right. I've shared two links on Collab on the WhatsApp group. These are for your reference. We will follow some of. We will pick and choose what feels good from those these Collab notebooks. Okay. I'll share my screen again. All right. So yeah, lists. People can follow this. Like I said, people can follow this. I'll come back and I'll do to and fro from this to my terminal. Okay. So lists. Yeah. First of all, the most important thing is you should know how to do this. Help list. Right. It'll list all the methods that list has. Ignore these dunder methods. These are called dunder methods, by the way, starting with double underscore and ending with double underscore. These are called dunder, double under. So dunder methods, right? Ignore these for now and start with the ones that don't start with that are not dunder methods, right? Append, clear, copy. So you should know how to do help list. Okay. So what is list in Python? Let's just call it, right? It returns me some square brackets, right? So a list in Python, you can think of it as a collection that can contain elements of any type, right? For example, if you want a list of all the fruits that are present, you can create a list from it. You can create a list. The syntax looks something like this: apples, oranges, and what else? Mangoes. I hope it's mangoes or mangoes, whatever it is. Let's just go with this. So yeah. So the syntax to create a list is square bracket start, an element, comma, another element, comma, and so on. So the elements in a list are separated by commas. By the way, is my terminal font visible, or should I change it to a lighter mode? I can do that if it's needed. Is this better?
Yeah, this is better. Leave it like that.
Okay. So yeah, this is a list. So if you go and see the Python official docs for lists, I think it's there in the Colab. So it says, first of all, lists are mutable sequences typically used to store collections of homogeneous items, right? We'll come to mutable in a bit, but this is what is important. And although people don't use lists in this way, if you use lists as a collection of homogeneous items, you can do very powerful stuff with it, right? What are homogeneous items, right? It just means that uh, items of the same type, right? So, for example, I can say fruits 10, 20, 30, right? This is a valid list in Python. Fruits, right? Lists can contain elements of any type. They have no restriction whatsoever, right? You can make a list of numbers, you can make a list of numbers and strings and whatever thing we have, floats, complex numbers, anything, right? So it can also do this 30.0, 45.5, 3.14, right? This is a valid list in Python, and it doesn't have to be just numbers in the start and then strings. You can mix and match. What would be this? Tomato, maybe, right? So this is a valid list in Python. Yeah. So a collection of homogeneous lists. What homogeneous elements? What does that mean? So in general, Python lists contain same type of elements. They don't have to, but in general they do. So I'll just create a list of numbers, right? Numbers is 1, 2, 3, 4, 5, 6, 7, right? This is a list of numbers. Alright. So this, all the elements are of the same type, right? So this is what you mean by, what Python means by saying homogeneous items, right? Homo means same, okay? And it is lists are mutable sequences. Okay, we'll come to it. Mutable. So is the syntax clear? But first of all, just let me know, is the syntax clear for lists? You start with square bracket, separate the elements with comma, end with square brackets. Okay. Is the syntax clear? Because lists are very important. Yeah. Okay. I'll take that as yes. So what things can lists do? So like these are, I've said that these are collection of same type of elements, right? First of all, what you can do is you can stick this list in a for loop. Okay, like we did with strings, you can stick this list in a for loop. You can say for number in numbers. So our list numbers is the numbers here. Okay, this is what you put after the in keyword here. For element in list. So the general you can say format is for element in list. Okay, let me comment this. For element in list, okay, it's not commenting. Do something, right? Imagine this is part of this for loop. Okay, so you can iterate over elements in a list, right? Okay. Second thing, what you can do, numbers. Again, we have numbers, right? Let's take another list. We have prime numbers, right? Let's say it's 2, 3, 5, 7, 11, 13, 17, right? What you can do is you can add to lists. Okay, you can add to lists. What it does is it creates a new list with all the elements of numbers and prime numbers. So if you think about it, it's very intuitive that a new list is created with all the elements of numbers and prime numbers, right? A new list has been created. It's not doing any let me just add two. Okay, it's 2 is here as well. So notice that in numbers we have 2, right? 1 2 3 4 5 6 7. Prime numbers also has 2. It has 3 as well. 5 2 7 also, right? So this numbers plus prime numbers returns a new list, and notice that the first 7 elements are from numbers and the rest of the element are from prime numbers. So elements in list have a defined order, alright, and when you add to lists, that order is maintained. So first all the elements of this list, then elements of this list. Okay. Third thing, let's see what numbers are. You can access individual elements of the list using the subscript notation. Remember from string what we did was this Ishan. We could access the first character of the string, right? Similarly with lists, we can access the first element of the string, right? We can access the second element of the string. Remember, counting starts from 0, like I said yesterday. Here as well, while counting positions and indexing, counting starts at 0, right? So first character is at position 0, second character is at position 1. Okay. Now can anyone tell me how do I get this 7? Just type in the chat, how do I get this 7? What do I put in this that I get 7? Okay. Jyoti says numbers -1. Yes. Any other answer? Numbers -1, correct. Lalita. So yeah, similarly with strings, you can do the same indexing with lists as well. To access the last element from or the first element from the end, just use negative indexes. Okay. And also similarly with strings, I didn't explain this yesterday, but you can do this as well. Alright. Oh, sorry. List index out of range. It's supposed to be minus. It's slicing that we can. So yeah. Also you can calculate a length of the list. Right? Len numbers. Remember, with strings I told you that you don't have an attribute or a property numbers.length, right? In Python you call the len function to get length of a collection or a sequence, right? Just a minute. Yeah, sorry for that. Yeah, where were we? Yeah, we can calculate length of a list as well, right? Using the len function, similarly to list. So you can see the cohesiveness of Python, right? What operations you can do with strings, you can do that with list as well, right? Similar cohesiveness. All right. And Yeah, we have done indexing, so let me just go back and check what if we missed anything. Yeah, so how do you create a, we've created a list numbers, right? This is how you create a list in Python. This is a list, literal you can say, a syntax to declare a list, right? How do you create an empty list? You just call the list constructor, right? Or empty square brackets. These are the same thing, alright? This is how you declare an empty list in Python. Again, we've seen that lists can have mixed element types, but generally they have elements of the same type, right? We have also seen you can access values similarly to strings, and yeah, this. So lists put no restrictions. Let's use this example only. So Python lists have no restriction on what the type of the elements are. So in fact, my bad. Yeah. So Python lists have no restriction on what elements you put inside the list. So what you can do is you can put list inside lists as well. So notice that this is the outer square bracket and this is the ending outer square bracket. And the elements separated by commas are themselves lists. Okay. So even inside this, I can go a level deep as well. I can do this as well, and this as well, and this as well, right? So you can nest things, nest lists arbitrarily. There is no limit. I mean, there is obviously a memory limit that is imposed by the resources on your system, but as far as Python is concerned, you can nest arbitrarily inside a list. Okay, these are useful for things like defining matrices, if you know about those, or coordinates for that matter, right? Collections inside, so collections of elements, list of collections of elements, right? So what is the type? We haven't looked at the type of coordinates, right? What does it give us? Remember, type is a function. We've used it already. So type is a list, all right? And similarly, type of numbers is also a list. Okay. All right. Again, we come back to numbers, and remember it said in the Python docs, lists are mutable sequences. What does that mean? What that means is effectively we can change the values, change the elements inside those strings. So I can access those, the first element using indexing, using the subscript operator, and it will give me 1. What I can also do is I can also do this, right? What it will do is it will replace the first element that is on the position 0 with 99. Now my numbers look like this. Alright. So remember, if you try to do this with strings are similar to lists, right? Let me just to reiterate the point. Name 0, you can access the first character, but if you go to assign it, strings will give you an error. str object does not support item assignment, right? Because strings are immutable. Immutable, right? Cannot be mutated. Immutable, right? Python lists are mutable, right? Can be mutated, right? They are meant for mutating. So again, numbers is this, and of course we can go crazy. Numbers 1 is 100. Again, numbers, you can access and change the values of those elements. Alright, I'm showing this for integers, for numbers, but you can do this for any type because lists can contain elements of any type. Okay. Okay. Then we have this. I won't cover the del operator because you shouldn't use it in normal circumstances. Yes, the in operator. So remember, in comparison operators, we mentioned that there is an operator called in and not in, right? For strings, it checks A in Ishan. It checks whether first string is part of part of second string or not, and vice versa for and the opposite for not in. It checks whether it's not a part of string or not. For lists, let's see numbers again. Numbers, right? What I can do is I can check whether an element is present in a list or not. So I can say 7 in numbers, right? What will this return? Can anyone type in the chat? 2. Anyone else? False, error, it will return, it will crash my interpreter, anything? True. Okay. Yeah. So 7 in numbers will check whether 7 is present in this list or not, whether 7 is an element of this list or not, right? Since in numbers it is present, sorry, it will return true. What if I had done this? What's the number that that's not in 101 in numbers, right? What will this return? Quickly, just type in the chat. False. Alright, it will return false, right? Because 101 is not a member of this list. Alright. So imagine these are comparison operators, right? They're returning boolean true or boolean false. You can use this thing, right? If in an if statement, if 6 in numbers, print, I found 6. Alright. So you can compose these things like we did yesterday, right? Because these are just expressions and return true or false. So you can use this in if statements as well, right? In condition of while loops as well, you can use it. All right. So next we cover list immutable. We covered that. All right. This is a thing that if you use Python for a bit, it might trip you up sometimes. Numbers, right? What I can do is this is perfectly valid in Python. Alright, this thing that I'm doing is perfectly valid in Python. What I'm doing is I'm creating a new variable, the same numbers, and I'm assigning numbers to it. So let's see what same numbers looks like. So it is the same list, right? Assigning this assigns the value of this variable to this new variable. Alright. So what I can do is just to see numbers and the same numbers together, right? This is 9900 3 4 5 6 7. This is 9900 3 4 5 6 7. What I'll do the same numbers. 0 equals 1000. Alright, and I'll repeat this thing. What changed will I see? Can anyone type in the chat if you know about this? Anyone? All right, I'll take that as a no. Yeah, notice the first element of those strings, because I'm changing the first element of the same numbers, which is this list. Right? Notice what happened. Right? I changed the first element of the same numbers. I changed it to 1000. I didn't touch numbers, right? I didn't touch number. I didn't say number 0 equals 1000. What happened was it also changed the first element to 1000. So what's happening here? Just to like get a bigger eraser. All right, I have space here, so I'll use that. So when you say numbers equals a list 1, 2, 3, and you say new numbers, new underscore numbers, a separate list equals numbers, right? We've effectively done this. What we did was we said the same numbers is equals numbers. So the second, the new variable is equals to the old variable, right? So what happens is when you define a list, when you say this line, what you do is you bind the name. Remember the binding thing that I've been talking about. You bind the name numbers to a list in memory which contains this 1, 2, 3. Right? This numbers is a label, a name. Right? This is a name. Numbers is a label for this list which exists in memory. Then you come and say this line, new numbers equals numbers. What it does, new numbers, it creates a new label, right? It creates a new label. Just is this. It creates a new label for the same list, right? So we say that these two names are bound, name bound to a value. So these two are just names for the same value. These two are names bound to the same value, or we can say they refer to the same value. You will see this word a lot, refer, right? So they refer to the same value in memory. So when I can access this list that I've created using this name or this name, right? Because they point to the same thing. So when I say new numbers 0 equals 1000, what I effectively do is I go follow this arrow, I change the first element to 1000, right? Remember, numbers is also pointing to the same list. So the change is also visible from numbers. Alright, is that clear? Is this diagram clear, right? These are both these are both different names for the same thing in memory, right? And this causes issues if things are mutable, right? Why did I mention this? Why did I not mention this while discussing strings, right? Because strings are mutable, right? You can't change it once you've created it. It's stuck in time, right? Sort of. So these sorts of issues that I change it here and it's also visible here. These sorts of things don't happen in strings. So that's why we didn't mention while discussing strings, right? Yeah, these issues arise because lists are mutable. All right. So yeah, we go to lists here. We've covered this. Lists are mutable, right? what if yeah, so what if I didn't want this to happen, right? I wanted a true copy of a list, not a reference to a list. So what I can do is get same numbers equals list of numbers, right? So what I can do is we saw this list function without any arguments, right? Now I am passing it a numbers argument. Numbers is, remember, our original list, right? It is the original, this one. This is the original list that we had. I'm passing it as in the list function, and what it does, it creates a shallow copy of list of my list, right? I won't go into shallow or deep copy because that would take more time. But remember that this creates a copy of a list, right? So yet same numbers, they have the same data, but if I change yet same numbers 2000, let's say I do it 2000, and I say numbers comma yet same numbers. Notice that it only changed it in the yet same numbers, right? Because we created a copy of the list. All right. Okay. Yeah, we've done this. We've done this as well. This are mutable. All right. So now we come to the methods of lists. So let's clear this. Our numbers list is this. Numbers, lists in Python, like I said, every data structure in Python is very versatile. Lists support a lot of methods, right? One of the few useful methods is append. What it does is it appends an element to the end of the string, right? So if I say, let's say 11, right? And I print numbers again, it printed, it added 11 to the original list. So it is mutating the same list. It's not creating a new list. It's adding the element to the same list. All right. Another thing as well, in Python, the length of the list is limited by your system resources, right? Python lists are of arbitrary length. You don't have to define a length prior like you have to do in C or C++ arrays. Python lists are closer to what you can call a linked list or a dynamic array, which a vector, if you know about those, that increase their size as needed, right? So lists can have arbitrary size in Python, right? So I can again append 100, right? And the numbers would have 100 at the end. So it appends at the end of the list, right? The right end of the list. Okay, remove. So I'll copy this example because. So my sentence is a list of strings, which is Python is sometimes fun, sometimes. All right. What I can do is I can say sentence dot remove sometimes, right? So this is removing the element sometimes from the list. So if you notice, there are two sometimes in the list. So will it remove the first one, the second one? Let's see. All right. Okay, looks like it removes the first sometimes it finds, right? But how did I know that, right? I'm not an expert in Python, of course. So what you do is, I told you could do this, right? You could also do a specific method of a list, right? If you're interested in just a single method of the list, you can say list.remove, right? So remember, we are using methods of the list. This dot is accessing properties, methods, attributes, whatever you want to call it right now, of that list. All right. So remove is a method on the list. So we can say help list dot remove and remove without any parenthesis, right? So you can see remove first occurrence of value, raises value error if the value is not present, right? So it clearly says that it removes first occurrence of a value. Okay. So let's move ahead. List.sort, this is very useful, makes sense for numbers, although you can do it with strings. I don't know where it would make sense with strings, so I won't explain this part, because sorting in strings is done with a different order. It has a different order of sorting than numbers are easy to sort, right? So let's go to numbers and numbers.sort, right? So notice that our numbers would now be sorted, right? These numbers are sorted now. So also notice that this dot sort method sorted this list in place. It sorted numbers in place. It didn't create a new list. It modified the list itself to sort the elements, right? So this is sort. Again, I won't. Okay, a sort has a. Now we know about keyword arguments, right? So we have a keyword argument reversed. Reverse equals 2. So by default, you can see that it sorted in ascending order. What if we wanted descending order? You could say numbers dot sort reverse equals 2. Right? It would sort in descending order then. All right. Like I said, numbers dot sort, what it does is, again, we'll sort it in the ascending order. Numbers, right? This is our numbers now. What if I wanted, I did not want the list to change. So let's go back to our numbers. Numbers equals back, not sorted, not this. This is also sorted. Time, let's do a new numbers, all right? Let's do a new number, right? Numbers equals 55, 12, 2, 1, 100, right? This is an arbitrary list containing numbers, right? Invalid syntax, go for it. So numbers is this list. So I just mentioned that numbers dot sort sorts list in place. So it modifies the numbers list. What if I did not want it to modify, because I'm going to use numbers later for some computation. I don't want it to be sorted in place. I want a copy of this list that is in sorted order. So again, Python has a sorted function. Why is it giving me this? So Python has a sorted function. If I enter, just notice what it will return, right? So it returned this list, but when I press numbers, my numbers is intact, right? It didn't get sorted in place. So this sorted is an built-in method in Python, built-in function in Python, which creates a new sorted list from the one that you pass in as argument. So again, it even has the same reverse argument. Reverse is true. It will reverse in the descending order as well, like the sort method on the list, right? Okay. Yeah, list.extend. Right. We have numbers, we have our prime numbers, right? So like I said, we created a new list out of numbers and prime numbers, right? But what I also told you was this is a new list. This is a totally new list which has nothing to do with numbers, nothing to do with prime numbers, right? And by the way, how am I saying that this is the same list or a different list? We haven't done this till now, but what you can do is you can use the is operator, numbers plus prime numbers. Alright, that is how I'm confidently saying that numbers plus prime numbers is not the same list as numbers. Okay, this is how I'm saying it. Is operator was mentioned here as well. We didn't cover it that time, but is the identity check operator. Alright, it checks whether ASB checks whether ASB checks are A and B the same object. It actually checks some other thing, but for our purposes, are they the same object in memory? Right? So we did one example, numbers equal, we have numbers here, right? And what I did, yet another numbers, right? Yet more numbers, right? And I even drew this diagram, right? That numbers and new numbers point to the same thing. They are the same object. They are just different names of it. So what you can do is you can confirm it through this. Numbers is yet more numbers, right? If it comes as true, the thing that you modify in yet more numbers will also be modified in numbers. You'll see the modification from both the names, right? This was just a tangent. I didn't want to cover is, but yeah, this is how you do it. Alright. So yeah, back to the agenda, numbers plus prime numbers, right? Numbers plus prime numbers. So what if I wanted to, so numbers is this, prime numbers is this. What if I wanted to add these numbers to the original list? What if I wanted my list to have these numbers and prime numbers as well, right? This, although this list achieves what I am saying, but it creates a new list, right? I want these prime numbers in my original list. So what I can do is I can say numbers.extend and I can pass in another list here. What it will do is it will take the numbers list and it will take the prime numbers list, and for each element in prime numbers it will add that element in the numbers list. So it will modify the numbers list. Alright. So my new numbers are now 51, 1200, which was the same as earlier, and now it's added the prime numbers as well. Okay. So this is the list, extend and reverse. Reverse is also a very useful method. So numbers, now numbers is this numbers dot reverse. Again, what it will do, it will reverse the numbers in the list. Right, it will just swap it. It will flip it, right? And you can see that it did that in place. So it modified the original list. Alright. What if I wanted to get a new copy of the list? So let me go back to the original numbers. Numbers. Yeah, that will work. Numbers is now 5512 to 1100. And what if I wanted to, like I did with sorted? So Python has an inbuilt function called sorted. There is a similar function called reversed. What it does is, reversed is a bit different, but let's see what it returns, right? Oh, it's numbers. All right, so sorted returned a sorted list, but reverse numbers is returning a different thing. I won't talk about this, what it's returning, but just assume that calling list on reverse numbers should return the reverse numbers, a new list of those reverse numbers, right? numbers are this, and to prove it, it's false. Alright. So yeah, we covered lists. We went through lists pretty quickly because we have a lot of things to cover. Yeah, any questions now? I'll pause for 5-6 minutes per question. Which type of sorting the method sort use, Rashmi? So in Python, as far as I remember, Python uses a sorting algorithm called timsort. You can read about it here. Timsort. Alright, it's a modified version of a classic sorting algorithm. I'll paste this link here as well. You can read about it. It's a slightly modified version of classical sort algorithm, right? What it does it is better in the cases where a few of the elements in lists are already sorted, right? So, for example, I have a list numbers this. So, in this, let's say I do it 1, 2, 3, 1, 2, 4, 6, 50, 66, and then 12. So you can notice that most of these elements are already in the sorted order, right? So elements still here are already in sorted order. This is the outlier here, right? So timsort is a modified algorithm for sorting that that does perform better in such cases. I believe that's the thing that you'll find it here. As long as I remember reading it last time. So yeah, I must have pasted this link and I add it to the list as well. Yeah, sorting algorithm. Right, I'm not sure if it uses this because I read it a long time ago, but I think it uses this timsort. Right. All right. I'll now pause for questions. Does anyone have any questions? All right. All right. No questions. Good. Satya, I think we can take a break here. It's almost 12:30. Are you there, Satya? All right. We'll take the lunch break now, and we'll reconvene in an hour. All right. Just mention it here. Break.